Hello everyone, welcome back. In this particular video tutorial, I'm going to teach you the second sorting algorithm in data structure, that is insertion sort. So let us understand what is insertion sort. Then I will give you an example with a C program to understand more about insertion sort. Insertion sort is a simple sorting algorithm that works similar to the way you sort playing cards in your hands. I'm sure that if you know how to play cards, it's easy for you to understand what is insertion sort, how this insertion sort works. So basically, when we talk about the insertion sort, the array is virtually split into a sorted and unsorted path. Then the values from the unsorted path are picked and then it will be placed at the correct position in the sorted path. Let us see this example. I'm sure that you can able to see an array. The name of the array I've said ARR. So in this array I have 6 elements starting from the 0th index up to the 5th index. I have stored some elements there. So according to the slides here, the array is virtually split into a sorted and unsorted array part. So here, this particular array, I'm going to split them into two parts. One is going to act as a sorted array, another one is going to act as an unsorted array. So here I would say the first part will act as a sorted array. So this part here is an unsorted array. So the reason why I'm saying this is a sorted array, let's consider my array has got only one item. When you have only one item in an array, that value will be stored into the 0th index. Then since the array has got only one item, so we can consider the array is already a sorted item, isn't it so? That's the reason why I had to consider this one as a sorted item. So now I have divided my array into two parts. One is a sorted array where there is a 0th index and its value. The other parts are called as an unsorted array. Now if you could go back to the slides and read this one, values from the unsorted part are picked and placed at the correct position in the sorted array. So let's say I'm going to sort this array in an ascending order. I'm sure that when you sort this array in an ascending order, the first value is going to be 20, followed by 30, 40, 50, 60 and 70. So this is how the sorted array is going to look like, but I'm going to use the insertion sort. So what I'm going to do, I'm going to take one element from the unsorted array. So in that case, that one element is nothing but what? This element 30, right? So I'm going to pick this 30. This is unsorted array. I will come to the sorted array at the moment. So this is my sorted array where I have 70 that is stored into the 0th index. I'm going to compare this 30 with 70. 70 is greater than 30, isn't it so? If it is a case, I have to shift this one position to the left. If I do that, what will happen? 30 will come here, 70 will go there, and then the remaining will be there as it is. So the 30 has come here, 70 is there, so 50 is there, 40, 20 and then 60. So now this is my sorted array, this is my unsorted array. So this is 0th index, this is first index. Now I have to pick one element from the unsorted array, in that case 50. Now this 50 will be compared against these two values, right? So I'm going to pick this 50 and then I'm going to compare with 70. When you compare 70 with 50, 70 is greater. So what does that mean? When you compare these two, the 50 will not just come here. The 50 will not just come here. So let's say this is an unsorted array. I'm going to create a variable. Let's say the variable name is value, and then that value is going to be 50, this value. So when I store this one into the variable, there will be a hole or a free space that will be created here. So what does that mean? When you create a free space here, the value will be stored into the variable. So I'm going to take this variable name called value. I'm going to compare with the first index. Compare 50 with 70. 50 is less compared to 70, isn't it so? When you compare these two, when this value is less, this value will move one position to right. When I move this one position to the right, what is going to happen? 30 will be here. Now there is 70 here. Now 70 will be moved one position to right. So it will come here. So here there will be an empty place. So I'm not going to place the 50 here. It will be an empty place because it used to be 70 here. When I compare this variable name called value, that is 50 with 70, 50 is less. So as a result, 70 is being moved one position to the right. Now this is an empty place, right? Now let's consider this is just a variable name called value. Now I'm going to compare this one with this one. 30, I'm going to compare them with what? 50. 50 is greater. Just because 50 is greater, this value will be replaced with 50. I'm not just going to bring the 50 there. Initially it will be a question mark. The question mark is simply means there is a variable with the value. Now the 70 has moved here. Now this one has become a sorted array. What is unsorted array now here? We have 40, we have 20, we have 60. I hope it's making sense. Now I'm going to pick one element from the unsorted array. First I'm going to compare with this one. 40 is less than 70. In that case, what is going to happen? Now what is the variable value? Is 40, isn't it? So I'm picking the 40 here. I hope it's making sense. Now what I'm going to do, the variable value is 40. Now this 40 that you see them here will be compared with 70. 40 is less than 70. So what is going to happen? It will be like this. 30, 50 is already here. Now when I compare this one is small. So this is going to be an empty, and then this 70 will be moved one position to the right. So in this case, this question mark simply is 40. The 40 will be compared with this one. In that case, what is going to happen? 40 is less than 50. So in the next step is going to be what? 30. 40. This was going to be a question mark. The 50 is going to move one position to the right. So this is going to be 50. This is going to be 70. Now this 40 will be compared with 30. 40 is greater. So this question mark will become 40. So now this is a sorted array. In the unsorted array, we will have 20 and 60. I hope it's making sense, right? Now in the next time, what is going to happen? We are going to pick this value 20. So in that case, the variable value will be 20. So I'm going to compare these two. When I compare these two, this is smaller. So this one I have to move one position right. So in that case, 30, 40, 50, there will be a question mark, then followed by 70, isn't it so? Now these two values will be compared. This is question mark, it simply means 20. So in that case, what is going to happen here? I hope you have already guessed. 30, 40, this 50 will be replaced with the question mark, and then the 50 will move one position to the right. That will be 70. Now this value will be compared with this one. 20 is less than 40. So in the next step, it's going to be what? 30. There will be a question mark here. 40 will come here. 50 and then 70. This is sorted array, right? This is a sorted array. This side we still have an unsorted array, that is 60. I hope you still remember. The 60 is still there. This is a sorted array. This is an unsorted array where we are just remaining with 60. So now these two values will be compared. When you compare those two values, I hope you have already guessed. The question mark will come here. 30 will go to the right. 40, 50, 70. This is sorted array. Now this is at the 0th index. There is nothing else to compare. So this is simply means what? 20. Now in the next iteration, we are going to pick this 60. So in that case, value will be 60. So this 60 will be compared here. When you compare that one, yes, 60 is less than 70. So in that case, it's going to be 20, 30, 40, 50, question mark followed by 70. I hope it's making sense. Now this 60 will be compared with this 50. 60 is too bigger, so this 60 will be replaced with 60. So we are not just going to replace it. We are not just going to place the value. We are going to check each position. This is what it means, isn't it so? Values from the unsorted part are picked and placed at the correct position in the sorted part. So if you wanted to place them in the correct part, you have to check all the indexes. Now we can see this array is a final sorted array. This is how we can sort an element using insertion sort. I hope it's making sense. So we are going to pick one element from the unsorted array. We are going to compare them with a sorted array until we find the right position for that particular element. So we are not just going to place them. It's going to be question mark, then we are going to move, then we are going to compare, finally we are going to place them. Now let us write the C programming function to understand insertion sort, right? So let's say for example here, as you can see them there, here, the first array is always going to be a sorted array, because let's consider if array has got only one element, it's going to be a sorted array. So now we are comparing the first index value with the 0th index value, isn't it so? So for that, I'm going to say for I is equals to 1, because we are comparing the first one with the 0, comma, then the total number of elements, in this case we have 6 elements, and then I'm going to say I plus plus. So inside, what I'm going to do, yes, I'm going to compare the first one with the 0, then we are going up to the number of elements that we have them here, followed by what have I done? Every element, before I swap, I store them into the variable name called value. I hope you remember, right? So here I'm going to say I have created a variable name called value. In that value, I'm storing what? This array of I, isn't it so? The name of the array, I said that A ara. I'm going to say I. What is this I? This value is nothing but, I hope you have seen them here down there. Every time when I wanted to pick an element from the unsorted array, I store them into the variable name called value, right? So in this case, I'm sure that you can able to see what is I value is 1 less than, what is n value? 6. 1 less than 6, condition true, then it will come here. Now this is array. What is I value? I value is 1. Then I'm going to store them into the variable name called value. So what is there in the first index? That is 30. So this 30 will be stored into the variable name called value, isn't it so? So now what is the value? Value is nothing but 1, isn't it so? This variable value is nothing but 1 because of this I. So I'm storing the I value because this is, excuse me, ARR of I. So I is ARR of 1. This one will be stored into the variable name called value. Now I'm going to create another variable, that is J. I'm going to say I minus 1 because I'm trying to compare them in backwards. So what is I value here? I value is 1 minus 1. That is a J value, which is nothing but 0. So the value, the variable value is 1 and then the J value is 0. I hope it's making sense. I'm creating this variable and then I'm referring to the array A of I, which is nothing but I value is 1. So the value is A of I. Then I'm trying to pick an element from an unsorted array, and then I'm going to the sorted array. So that's the reason why I minus 1. In that case, J value is equal to 0. Now I'm just going to write a while. I'm going to check two conditions. The first condition is whether the J value is greater than or equal to 0, and let's say an ARR of J, because ARR is simply means this name that I have given them here. ARRI is greater than the variable value. So now I'm going to check what is the J value. J value is 0, greater than or equal to 0, condition true, right? And what is ARR of J? That is 1, isn't it? So ARR of J is what? I'm sure that the J value is 0, greater than or equal to 0, and ARR of J. What is J? J value is still 0, right? So the 0th index value here is what? 70, greater than value. What is value here? The value that has been stored into the first index. What is the first index value? 30. This condition is true, even this condition is true. If these two conditions are true, I'm going to write the logic. What do I need to do? I need to swap, isn't it? So I need to bring this one, I need to bring this one to the right, isn't it? So I need to bring this 30 to the right side. So if you wanted to bring them to right side, I'm going to say a ara of j plus 1 equals a ara j, and then the next step j is equals to j minus 1, and then down there I'm going to say like a ara j plus 1 is equals to value. So what does that mean? Let me just explain it. Yes, if this condition is true, a ara of j plus 1, which is j plus 1 is 30, isn't it so? So a ara j, what is this a ara j? This is 70, this is j plus 1. So this 70, put them in j plus 1. So move this one to the right. And j minus 1, what is the j value? J value is 0. Remember, j value is 0. 0 minus 1, j. Now what is the j value? J value will become minus 1. When the j value becomes minus 1, here I am going to come and check the condition. So it's no longer 0, it's going to be minus 1. Minus 1 greater than or equal to 0, the condition fails. If the condition fails, this whole while loop is not going to be executed. It will come outside. When this condition fails, it will come outside the loop. What do you see them here? Value. The value is simply, what do we have them here? The 1. So we are going to swap this one here, and then we are going to swap this one here. We are going to bring this one here. So ARR j plus 1 is equals to value. So this is how insertion sort would work. So basically we are going to divide the array into two parts. One is a sorted array, another one is an unsorted array. From unsorted array, we are going to pick one element at a time. Then we will come to the sorted array. We are going to place that item in a corresponding place. So we have to check all the indexes. Then we need to place that unsorted element that you pick them from the unsorted array into the sorted list. So this is how insertion sort would work in data structures and algorithm. If you have any questions, you are free to ask me. Thank you.